Hi, welcome to Live Life Ravishingly. Today we are continuing it with our session of AI. So we have Mr. Shivaram. Welcome, Mr. Shivaram.
Hello Ravish, how are you?
I'm super. How are you?
Doing good?
Thank you. All right. So we have been speaking AI everywhere. So we want to learn what exactly is AI. Tell me, Shivaram, what is AI?
Okay. So just to tell you, I've been in the field of AI for last 20 years. Okay. Um, when I was doing my engineering,
Mm-hmm.
I decided I wanted to learn AI because it was very interesting. I felt this is a very interesting topic.
Right.
I wanted to understand how human brain works,
Uh huh.
and the closest thing which was there was AI. Right.
Okay. All right.
So when I started doing AI, even then it was called AI,
Okay.
but we only had machine learning. So I'll be talking about what machine learning is and so on.
Right.
So AI is a way to teach algorithms. I'll tell what algorithms are to learn by themselves.
Okay.
Okay. So before I go into AI, let me explain how computers work.
Oh, okay.
Okay, because you need to understand. This is for general public. So I'm trying to start from the basics.
All
Okay.
right.
So how computers work? So computers have something called as hardware. Everyone knows, oh, it works in zeros and ones. People
Right.
know that, right?
Right.
But what is happening internally in computers is we have a set of things we can do with that hardware.
I see.
Okay, so
Okay.
set of operations, or
All
we
right.
can say set of blocks are there, like Lego blocks. The set of blocks are there.
Okay.
Okay. Now, what these operations should do is programmed by humans.
Okay.
We write computer programs, we write programs. So what we are doing in the program is to tell which operation in which order it has to run.
All right.
Okay, so imagine using Lego blocks and building a ship out of it. And you can also build a castle out of it.
Right.
You can build whatever you want, right? Because these are small blocks, they can be joined in whatever way.
Right.
Similarly here as well, we use these instructions which are there in the hardware in a particular order, okay, to get our work done.
Okay.
Okay, is computer smart? Is it intelligent? No.
Okay.
It is not intelligent. It
Okay.
doesn't know what it is doing.
Right.
Even though it is doing something, it doesn't know what it is doing.
Right.
Okay, we need to tell what it is doing, only then
Right.
it will know what it is
Absolutely.
doing. Okay,
Yeah.
so now imagine there is a robot or a machine. You want the machine to go get milk from a shop.
Right.
So you have to write each and every instruction. If you are writing a program for doing it, you have to write each and every instruction.
Right.
Like, move forward, turn left after 3 steps, like, after 3 feet or whatever, 3 inches or 3 meters, turn right, then open the door. To open the door also you need to tell. You cannot say open the door. You should say move your arm by this much degrees, then hold it, then turn by this many degrees, then push. So all these things you need to tell until you go to the
Milk booth.
milk shop, milk booth, and bring the milk.
Right.
Right. Now you can easily guess how many problems can happen in real world, right? When
Right.
imagine you are telling a machine to do this. When you were building the code, the road was in particular way, and after that the road got destroyed, or some problem happened.
Right.
Entire program goes for a toss, because if by chance if it leans to a particular angle or falls, it will not know how to get up.
Right.
And after that what to do, it will not know. So it is almost impossible to write programs.
Uh-huh.
You can write programs for computers to do calculations. You
Right.
can say to multiply 2 with 100, you can take, you do this operation, that operation you can do.
Right.
Complex things, scientific things also you can do in the computer. But in the real world, to ask a machine to do something, it is almost impossible.
Right.
Using programs,
Yeah.
normal programs, giving all the instructions, all the possible instructions. So people initially were trying to bring in intelligence. So let me tell you what artificial intelligence is. So we know intelligence is normally present in the living world.
Absolutely.
Not just humans, animals also have intelligence.
Yeah.
Right? Animals can go gather food, they can go hunt,
Yeah.
they can do various things, right? So animals are smart. The same kind of intelligence can we bring in things which are artificial in nature, in the sense non-living things.
Right.
Okay, that's where people started trying out various ways of bringing in intelligence into mechanical things.
Right.
Okay, so artificial intelligence is the process of doing that.
Okay.
It is not real intelligence.
Right.
Okay, there is nothing real about it. Even the algorithm itself doesn't know what it is doing, but it is
Right.
doing it it behaves intelligently.
Right.
See, when you see a particular building, you once someone has built it, when you see that, you'll say, "Oh, what a marvelous thing!"
Yeah.
Right? So it is something like that. Once you build the algorithm, it is doing something. You'll feel, "Oh, it is doing something intelligently," but it is not actually fundamentally intelligent as we know it.
Right.
Okay.
Right.
Now I will tell you how the boundaries are blurring in the later part of the video.
Okay.
But for now, let me tell you a little bit of history.
All right.
Okay, so this artificial intelligence is not a new concept. It has been there from 1960s, 1950s, 60s.
Oh.
People started doing it.
Okay.
Okay, they thought, okay, let's try to understand how human brain works and let's mimic it. So they saw the cell, like neuron, like our brain has neurons.
Right.
So they saw a neuron. They thought, okay, let's mimic this. They had some success.
Okay.
So they could build games, small games, and they could win in those games.
I see.
Nothing complex, all small things.
Okay.
Okay. But when they started, then they thought, they were like, oh, if we can solve this, then we can solve that, then they can solve. They were like fully excited. Oh, we'll solve off everything. But then they fell into a pit. So all their expectations went totally against them.
Okay.
And we call that as a AI winter.
Okay,
Whenever
all
this
right.
high expectation comes
Right.
and people are not able to achieve what they thought,
Correct.
it's called AI winter. We have been through two AI winters.
Oh, I see. Okay.
One is during 60s, 70s when
All right.
people were excited about AI and they thought everything they can do, but they couldn't achieve. Another during 90s and early 2000.
All right.
Okay, where people thought they can do, at that time they were using machine learning, and they thought, oh, machine learning can do a lot of things, but they couldn't deliver.
Okay.
Okay, so and now we have the current time. We don't know when the winter is going to come.
Okay.
Okay, but I don't see the winter coming yet.
Okay.
It may come later, but we don't see the winter yet. Okay, so now these are the things which are happening.
All right.
Okay. AI is to build intelligence into algorithms so that they behave in an intelligent way.
All right.
Okay, and this can be achieved in multiple ways.
All right.
One is extensively writing algorithms which will interact with each other and give intelligent output. Another is to train the algorithms, make the algorithm to learn from the data automatically.
Oh, okay.
Okay, that part of AI where we are training the algorithms to learn from itself, learn from data, is called machine learning.
Oh, okay. That is ML.
That is machine learning. So if you think about machine learning as a concept, it is a very powerful concept.
I see.
You know why? Because all you need to do is give data.
Yeah.
Okay, and the algorithm has to learn on itself.
On itself, right? Yeah.
But it is not that simple. We need to give a lot of hints to the algorithm. Like we call that as feature engineering, feature selection, and all those things. That means we need to tell what are the important things in the data it has to look at.
Okay.
It will not know. It doesn't have common sense. It doesn't know.
Right.
Like for example, if I have to measure the temperature at this particular place, right? What are the factors? Like obviously, have they switched on the heater?
Yeah.
What time of day it is?
Right.
Right? How much sunlight is falling?
Right.
Okay. What is the material on which we are measuring the temperature? Is it black in color or not? Black or white?
Right.
So these are some of the factors which may influence the temperature, right?
Correct.
But if you just give junk data, it will still take and it will try to find correlations and it will try to predict something.
Right. Right.
Okay? So this is called feature selection, feature engineering, which we do in machine learning, so that these algorithms learn well.
Okay.
Okay, and then there is deep learning, then there is reinforcement learning, different things.
Okay. Tell me one thing. Can anyone develop these models?
Okay. So, good question. If you want to develop your own new model, which nobody has built, for that you need a lot of knowledge. Okay. You need to know maths. In maths also you need to know specific different kinds of things like linear algebra, calculus, information theory. A lot of things you need to know. Okay, and I would say if you are a new person today, if you are going into the field of AI, you don't have to go there to
Okay.
become a AI person. You don't have to go there and learn all these things, like how to build a new algorithm from scratch. No, not required. Using a existing algorithm, it may take, like, and remember, there are not one or two algorithms. We call them as models also. It's
Right.
not like one or two models. There are maybe hundreds of models.
I see.
Each one behaves in different way, so you should know which one to use where.
Okay.
Okay, in the
Alright.
traditional machine learning, I'm saying.
Okay.
Okay, for that you need probably 6 months of training,
I see.
specific training, and if you have background in programming, then around 6 months to learn how to use these models and learn the concepts of AI to
Okay.
do this.
All right.
Okay,
Okay.
so let me also tell about deep learning.
All right. Yeah.
Deep learning came into picture in uh, 2012.
All
Okay, it
right.
became popular in 2012. What happened was AI was so bad earlier, it couldn't detect what is the, like, if you show an image of cat and dog
Uh-huh.
and ask it to differentiate, it was not able to differentiate.
Oh, okay.
Just 10, 15 years ago, it was
Oh,
not able
yeah.
to do.
Right, right.
Then some smart people came together. There were many things which came together. One is data. I told you, right? AI needs data to learn.
Right, right.
So a person in US, Fefeli, she basically started an initiative to collect huge number of images.
Right.
It's called ImageNet data set. That is one thing. They collected huge number of data set and they told in this image this is there, and like we have to tag. So for the AI to learn, we should know if we are giving some input, we should know what the output should be.
Right, right.
Then only does the mapping between the input and output.
Mapping. Yeah, yeah.
That mapping is the learning. Okay, but there are two kinds of things. One is when I am telling something to someone, they can exactly memorize.
Right, right.
Okay, if I show this as a cat, and if the cat turns this side, if you say this is not cat because it turned this way, that is
Yeah.
not intelligence.
Right,
That is
right.
memory.
Okay.
Okay, you're exactly taking the photo and matching. No, it should generalize.
Right.
What is generalization? It should know that even if you take the photo of the cat from slightly in a different angle, it should say that's cat. Even if I
Okay.
bring a Egyptian cat, it should say
I
it's a
see.
cat.
Okay. Okay.
It should know all kinds of cats.
Generalized.
Right? Generalized version
Yeah.
of learning. So
Okay.
for that, you need so much data.
Okay.
You need to show. See, we have seen different kinds of cats.
Right.
That's the reason we know.
Yeah.
How will AI know? We should
Right.
show it, no?
Right, right.
So that huge data set was created by Fefeli.
I see.
Okay. So then there is another person called Jeffrey Hilton. He's considered one of the godfathers of deep learning.
Okay.
What he did was, he thought earlier what was happening was, when I was doing my masters, I went and spoke to my professor. I told, see, here is a model, and if you this is the output it is giving. I'm going to neural networks I was using.
Yeah, right.
And I had 3 layers. I was like saying I'll put 7 layers, it will give even better results and so on. My professor said, don't do that. Then he told, that was the first time I heard it. He said there is something called as vanishing gradient problem. That means more layers you put, it will not perform well.
Okay.
The AI will not perform well. The neural network model will not perform well.
Okay.
So we humans have multiple layers of neurons. It still works. But in our normal, when we were building AI back in 2007, 2006, I think,
Okay.
it was not working. Right?
Okay.
Then people came and they came out with various new ways of preventing this vanishing gradient from happening.
I see. Okay.
Okay, this problem was removed. So they could build bigger and bigger models.
I see. Okay.
Models means more amount of more capability, more compute, first thing, and more capability for you to solve tougher problems.
I see. Okay.
Okay, I'm simplifying everything. I'm
Right,
not
right.
using the actual jargon.
Got it. Got
Okay,
it.
so you can solve more bigger and tougher problems using more layers.
Got it. Got it.
Okay, so like it's like the information comes to one layer, and after it goes to next layer, and each layer you solve part of the problem, and then you combine it and you solve a bigger problem.
Okay.
At the last layer, you get something which is meaningful. That is the output.
Got it.
Okay, so this is how neural networks work.
Okay.
One type of model. This is one type of model.
Okay.
That's how it works. Now this is how people started building larger and larger models, because that issue was solved.
Okay.
They did a small trick and it solved.
Mm-hmm.
Because of that, they started getting accuracies like earlier the accuracy was 55, it's jumped to 75.
Oh, okay.
That's a huge jump.
Huge jump, yeah.
They thought it will take, because before that it was like 54.5, then 55. Every year it was increasing by 0.05,
decimals.
0.5 like that.
Yeah.
Suddenly 20% increase.
I see.
They were like, oh, we are doing something correctly.
Ah.
Then they started using huge, more number of compute, more number of this thing, models, more number of layers in the models and so on. So they started getting very good results.
I see. Okay.
So by 2018, 2019, they had models which were doing better than humans in recognizing what is there in the image.
Fantastic.
Okay.
All right.
So this is deep learning.
All right.
Then there is also another concept called reinforcement learning. So I'll brush through it. So what that is in a, see, not everything is about you already have the data, training data. So that is input and output data, and you give it. So in image case, yes, you have an image. If there is a cat in it, you will say, oh, there is a cat, and you give it to the algorithm. The algorithm will learn, if the image is like this, cat is there. If the image is like this, cat is not there. If the image is like this, dog is there, and so on. And it learns using that. Okay, it will only find out what are the relations. If like this, if the pattern is like this, oh, maybe then the cat is there. So it learns that over huge amount of data. But not in other cases, you may not have such situations. Like for example, in the board of chess,
Yeah.
how will you create training data that way? No,
Correct.
because your end result will come only at the end of the game.
Checkmate.
Checkmate.
Yeah.
In the middle, you will not know whether you are doing correctly or not. So you need a different way of learning, different way of creating data.
I see.
Okay, how do you create data? You cannot show boards like snapshot of the board, images of the boards, and ask it to learn, right? So that's difficult. So one way of doing it is creating an environment, like a real world environment, and allowing the agent or the algorithm to move around the pieces and see what happens.
Okay.
That is one. And also they also brought in, there are new concepts that have come in like self play and all those things, where the algorithm plays with itself and learns.
Okay.
So it does one move, and it on the other side also there is an algorithm, same algorithm moving the other move, and it sees what happens, whether its chances of winning has increased or reducing,
Right.
and so on, right? So this kind of setup where the data is totally different, data has to be generated. It is not given, it's generated during the process of learning.
I see.
Okay, and then used for reinforcing certain aspects of learning. So which actions to take? Certain actions are given more importance, certain actions are given less importance. It's called reinforcement learning. So once again, here you use the algorithm, and in every algorithm, right, finally it's a mathematical model. You should know what is the algorithm. It's a mathematical model.
Yeah.
So mathematical equation. Now that equation, you are either trying to maximize something or minimize something. What are you trying to maximize? You are trying to maximize some output. Like if it is a chess game, you are trying to maximize the wins. Or chances of win and things like that.
Right.
And if you are trying to minimize, you are trying to minimize the error. Like I was talking about the temperature prediction.
Right.
It is predicting some temperature, and the actual temperature is something else.
Right.
You find the error, you minimize that.
Right.
Okay. Yeah.
That's great. Okay. All right. So as I said, how will you train the the machine? Like how exactly you train the machine?
So to train the algorithms, we collect data.
Okay.
Normally, typically, I'll tell what will happen. You have huge amount of data. You need a lot of data.
Okay.
It depends on the kind of problem. You divide the data into two chunks.
Okay.
Training and testing. Sometimes you divide the training also into other parts and all those things, but normally you divide the data into two chunks, training and testing.
Okay.
The training part is used for the algorithm to learn the relation between the input and output.
Okay.
There you give both input and output to the algorithm.
I see. Okay.
For the model to learn.
Okay.
So the model learns, it finds out the relation between the input and output.
Okay.
And it says, from my learning, this is the possible, this is the accuracy. Accuracy is a metric. There are multiple other metrics. Accuracy is one of the metric of measuring how good this model is doing.
I see.
Okay. And then once that is done, you test the same model on the data which it has not seen during training.
Oh, okay. All right. All right.
You know why?
Because it should work in the real time environment.
Correct. Not only that,
Uh-huh.
models can buy heart.
Okay.
So
Okay.
they're like humans, like whatever human mistakes people do, they can do the same thing,
Same
right?
mistake. Okay.
So you want to know whether the model has learned the things in a much more has it generalized or not. We use the
Uh-huh.
word of generalization.
Generalization.
Generalization is to learn something
Mhm.
in a totally new environment, like learning the concept in such a way that in a totally new environment you can perform well.
Okay. Right.
So now if the accuracy is good,
Mhm.
I'm using the word accuracy, but it can be any other metric.
Mhm.
If that is good in the test as well,
Mhm.
then you use that model and you say this is trained, and
Okay.
we'll start using it in production.
Okay. So with all these things, I think there is some concept of generative AI, right? This will come into picture if I'm not wrong.
Yeah.
Uh,
So
yeah.
you must have used
Yeah.
ChatGPT.
Yes. ChatGPT. Very much. Yeah.
ChatGPT is a generative AI model.
Okay.
Okay.
All right. Give me just go more
So
about generative AI. Yeah.
AI
Go ahead.
can be used for solving multiple types of problems. The ones which I mentioned, cat and dog, differentiating cat and dog, or if cat is there or not, things like that. It's called a classification problem.
Okay.
That is, you are classifying, saying this is there, this is not there,
Yeah.
right?
Right. Right.
So measuring the temperature, predicting the temperature, it's called a regression problem.
Regression.
And then there are problems like generation problems, right? Can you basically understand, like I will show various images. Can you generate an image similar to this?
Can you generate a new
Generate a new image
image? Yeah.
similar to this,
Uh-huh.
right? It's a generator
Uh-huh.
generation problem.
Okay.
Okay. Now, it is not just that. It can be used in text also. We will
Okay.
show a lot of books.
Right. Right.
Can you generate your own book
Your own book by reading that by
by reading all these books?
books. Yeah.
Okay. So it's a generation problem.
Right.
Okay.
Right.
So you must have heard of large language models,
Yes.
right?
LLM. LLM.
LLMs.
Yeah.
So large language models are generative models for text.
Okay.
What
Okay.
they have learned is to predict next words or words in between. Like, for example, what happens is they take huge amount of text, and the training data is the text itself. They give fill in the blanks kind of thing. Like,
All right.
there is
All
a
right.
blank,
All right.
the algorithm, the model has to figure out what is there in that blank.
All right. Okay.
Okay, they just has to learn. So when it is trained on huge amount of data, entire words data, okay, then what it will know is when you start with something, it will start generating the next word, next word, next word, and so on. So
That is generative AI.
yeah,
Okay.
it learns how to generate the next set of characters.
Okay. All
So
right.
now this is a language model. A model trained on a particular language on generating text is called a language
Language
model.
model.
But since they are large, they are called large language models.
Large language models. Okay.
Now these models are conditioned to answer questions. So there what you do is, if you just start with something, it will start answering. You don't want that. You want it to answer the question what you have asked.
Right. Right.
So then what you will do is,
Specific.
so you will condition the algorithm, large language model, such that given this text, instead of generating something randomly,
Random.
like or next words and so on,
Yeah.
it is conditioned to generate the answer as the next set of things.
All right. All right.
Okay.
Okay.
So that is how ChatGPT is able to answer your questions.
Got it. Got
It
it.
has been trained that way.
Okay. All right. So we speak so much about AI, so much about AI. What is a misconception among people on this AI concepts?
Okay. So there are a lot of misconceptions. People think AI can like learn on its own. Like for example, there's a AI product. They are using it. They think, oh, it'll next time when I come, it knows all my preferences and it'll learn on its own and things like that. They go to the extreme of AI becoming so intelligent that it's going to take away all our jobs and so on.
Right. Right.
So there is a very high risk of a lot of people losing jobs.
Okay.
Very high risk. And it is going to happen sooner than later.
Oh, okay.
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 Even then, AI, unless we train AI in a specific way, it cannot do anything it is not trained on.
Right. Right.
It cannot like generalize the real world scenarios. The main problem with AI today is it doesn't know how the real world works.
Right,
It's
right.
mostly given books, videos of like autonomous cars. They are giving huge amount of videos, or a particular robotic process, they are giving that process
Data.
information.
Yeah.
So they are very domain specific. They are not generalists, and they don't have the concepts of the way humans interact.
Yeah.
Those concepts have to be taught to them.
Right. Right. Based
Okay.
on the learning, it will
Yeah.
act.
So
Right.
people have this misconception that already if AI can do this, then it knows this also, that
That
also.
was,
No,
yeah. Right.
it knows that. That's it. Like, obviously, it knows other things similar to that.
All right.
It doesn't know everything.
Right.
It can be trained. I'm not saying AI in the future AI is not capable of doing something. It is capable.
But domain based.
Domain based.
Yeah.
In the future, it will become generalized. People are predicting within 1 or 2 years it will happen. So let us see how it happens.
All right.
Um, I feel so. I had predicted 10 years ago that people are going to lose jobs
Oh,
because of
okay.
AI.
All
I
right.
had, back in 2015, I had done
Right,
that. Yeah.
right, right, right. All right. So we'll continue our discussion on AI with Mr. Shivaram. Stay tuned. Thanks, Shivaram, for
Thank
joining
you.
us.
Thank you.